Okay, today we're taking a look at factoring linear expressions. I just got a couple simple examples here. Basically, what we're doing is using a greatest common factor to pull and reduce and kind of get a common factor and pull that from these two terms here. So what you want to do is, okay, yes, both these terms can be divided by 2, but go one further, they could also be divided by 4. So what you're doing is taking the 4 out of the 4x plus 2, and in turn getting 4x plus 3. Now where did the x and 3 come from? Well, this is, if we did 4x divided by 4, that leaves us with an x. And conversely, if we did 12 divided by 4, we would also get this 3 here. And that's essentially what you're doing as far as factoring. Now, you may not always end up with an x in the parentheses. For instance, the greatest common factor of 6 and 9 is 3. So what we're doing here is 6x divided by 3 gives us 2x. Minus 9 divided by 3, which would give us 3. And this is how we would factor a term such as this. Another one you want to look at is maybe one where they give you a fraction. And since this denominator matches up, you know that 1/2 could be a factor of 3/2. So I'm going to factor out the 1/2. Now, if I did 1/2 x over 1/2, just like this problem here with a 4 factored out the 4, this 1/2 is going to factor out the 1/2, leaving us with x. Little bit different though once we get to the 3/2. So basically you're doing negative 3/2 divided by 1/2, which could be written as negative 3/2 divided by 1/2, or negative 3/2 times 2 over 1. Now, what we would do here is just multiply across, and we would get that negative 6 over 2, which could be reduced to a negative 3. And that's how we would factor basically this here. And it makes sense because how many halves do I have in 3/2? I have 3. This video should help you with just some simple factoring questions.